Okay. So what you hear is the rack in action. You hear an eventer, the arpeggiator, you hear a synth that we can, of course, modulate or change. And you hear the effects. So we have one effect and two effects. We have actually two delay effects chained. And yeah, you get some clicks and stuff like that. It's not perfect, but the thing is that the chain of having an eventer and synth and effects, that works now. So I'm going to walk with you through some things in the server that is really cool, and then we go to the front end and how this is now being correctly shown in the front end using Svelte, the Svelte framework. So that's quite fun. So I will jump to that now. So let's go to the server. Now and the server is written in C++, right? So I can just show you. Here it is, and we're starting it up, and boom, just like that, it starts up. And we need to load a project, and as I said, the front end is web-based. So just for this loading a project, we have just an RPC endpoint. That should not naturally be something else later. I will show you that in a bit. And now we have the project running again. Okay. Server in C++, and what's happening in the server is that it's multi-threaded. Here is the chain of units, and I guess you can realize what this is about for yourself. These are MIDI processors, a synth that also accepts audio in real time, and then processing that to effects. Okay, and then we have. I want to show you also the that thing that I'm really happy about is that I was able to. Because when you dial the knobs here, you want the sound to be affected immediately. So the MIDI is processed by the audio thread, and that is then processed through a queue to another thread, because that is how multi-threaded things is written in C++. It's really fun to learn, and once you get your head around it. And just as a shortcut, I can say that threads, I think of threads as separate floors in a, let's say, 10-story building, 10 floor building. There's one person running around in one floor, and there is no chance that he will collide with anything or anyone. And then if we want to interact with some other thread, he has to push a message on a queue. That's like an elevator. So up or down, it goes to some other floor where there is another person dealing with that. So here we have, for example, the player engine processing that new knob values, throwing it away on a queue so that it can be sent to the web to the front end, so we can see, for example, that a knob is changed or a key is pressed, but also sending it to another queue so that this value can be saved to the project. So whatever changes we are making, we will always have a perfect copy of that project outside the audio thread. And if you have seen other DAWs maybe and also older synths, you know that that is a struggle to have the copy of the audio parameters outside the audio thread, because that's a bit tricky. But here it's solved through two queues. First, the queue to the front end, and then a second queue to store it to a data store in the server. Right? Threads is really fun once you get your hang of it, and all this anything that is related to the audio thread has to be non-locking, non-blocking, no mutexes and stuff like that. But then outside there can be mutexes.